Hey, welcome to yet another video on coding by ProductManagd. So here, I think the focus, especially I think from product management interviews perspective, is to give you an idea of the different kind of data structures and give you some of the most common application areas, and also help you understand what are the kind of I would say mostly interview questions that you can get in the product management technical interview rounds. Generally, the way I would classify, I think product management interviews would be by the different kind of companies that you aspire to be part of. Very technical bucket, and then probably rest of all the companies, right? So this is probably for both very technical and technical companies, where you are expected to know the data structures. How do you actually do operations in those data structures, right? So remember, in the last couple of videos, which is coding by product managed, we had touched upon list and operations, and then the advanced list operations, right? So today we are going to discuss trees. Trees are also a data structure in Python and in other programming languages, also Java, C++, right? It represents a hierarchical relationship between the elements, right? And what are these elements? We'll talk about those. The elements are basically nodes. You have your parent node, you have your child node, and then you can obviously associate nodes with values. Right now, what are those values? We'll discuss. But typically, a tree, right, looks like this. It has various levels, and the final level is basically called the leaf node level, wherein you have only the leaves. So if you see, for example, if you start from here, which is, if you want to call it, you'll probably call it as a root node, and then from the root node you keep on traversing in one direction, or going down. So level 0 is where the root node is, and all of these other nodes are called the child trees, the child nodes. And then you keep on traveling until you hit the leaf nodes, right? From level 0 to the leaf node is what is called as the depth of the tree, right? And there are different kind of trees that are supported in or the ones that you can create in Python. So for our discussions, I'm just keeping it pretty simple and straightforward. We have three tree types, and the source is an image, source image from Google that I have taken, and essentially here the trees are given terms based on the maximum number of children each node has, right? So if you look at binary tree, for example, a binary tree can have a maximum of two child nodes. So here, if you look at it, this is the root node, right? It's start going level down. You're seeing two nodes, and then the final level also has a maximum of only two nodes, right? Similarly, you have a ternary tree which has a max of three, child nodes, and then you have an n-ary, which is also called a generic tree, wherein you can have as many number of nodes as you want, right? The important part about these is that every tree is basically defined by the number of children, the max number of children, right, that it can possess, right? So the naming is basically binary, ternary, and n-ary are actually derived out of the maximum, number of children. So binary, for example, has a maximum of only two children, which means that it can have 0, 1, or 2, right? Child node. Ternary also a maximum of three children, which means it can have a max of three, which means 0, 1, or 2, right? And then n-ary obviously is called generic, and then you can have as many number of nodes. Okay. Now coming to the operations of trees, right? What are the operations that you can have in trees? So remember, I think from list where we had operations like sort, pop, delete, right? We also had append, right? Those sort of operations is what you actually want to have associated with any data structure, correct? So, what are the operations that are available for trees, right? So, you can do an insert, you can do a deletion, you can do a creation, and you can do traversals. Insert, as the name suggests, right? I mean, if I want to insert an element, I should be able to do it. I'm not covering the programming syntaxes of it. I think I will do that, and I plan to cover those with some algorithms of, let's say, the binary search tree in the next episode. So here in this episode, I'm just generally giving you an idea of what are trees and the operations, the use cases, applications, all of that, right? So now coming to the operations type, there are four, and if you do probably a Google search, you'll find even more operations. But these are the most commonly used operations. Probably also expected in the interviews. If you go for software engineering interviews, yes, there will be a lot more operation types that you'll have to remember. But I'm talking from a product management perspective where you should be okay, I think, with knowing these operations. For traversals, right, there are three type of traversals. There's a pre-order traversal, there is a in-order traversal, and then there is a post-order traversal. So traversal is nothing but the way you are actually going from the root node to the child nodes and down the levels, right? So remember, this is the level, and then traversing means from level 0 to level 1. How are you going from level 0 to level 1? So from level 0 to level 1, you can go in three. In this example, you can go in three directions, right? You can go to this node, which is on the left node. You can go to the center, or you could go to the right node, right? So traversals form an integral, like I think, part of the operations of trees. Now coming to the application areas, I haven't listed an extensive list of application areas. I'm sure there are not just couple, but there are definitely more than couple of areas. But just to give you an idea that why should you care about trees, right? And specifically in tech products, right? Why do you care about understanding what are trees, right? So imagine you are looking at a product where you have to create file system folder structures. Any product you pick, right? Whether it's a photo application or whether it's a Google Drive kind of a, application, whether it's a simple file based a storage system, correct? uh, it is all got trees implementation, right? The reason I think why trees are preferred is because it's memory efficient, and when it comes to navigation, right? And then also when you're searching for elements, right? So if you're looking at files, for example, right, within a folder, and it becomes very easy, if you have stored the elements in a tree format, right? And database indexing also, for example, uh, you can use trees for searching data elements and also information retrieval. So by information retrieval, I mean the actual elements, right, and not just the pointers that are actually pointing to the nodes, right? Um, Example of trees in Python. There are a lot of kind of trees. I think we'll focus today on binary tree, but I will post videos of the other tree types. But I think the objective of these videos is to give you the idea of one particular tree type and then go deep into that and see, I think, what are the operations that you can do, right? And as usual, I mean, I think we'll look at Python examples, right? So binary tree, I think, right? Remember, I think it is a child, it has a root, and then it has a max of two child, right? So here, basically, a node, right, which could be a parent node or a child node, will have data. It will have pointer to the left and the pointer to the right. What is a pointer? Like you should be asking this. If you don't know, please leave a comment in the video. I'll try to explain it in the comments. But pointer is nothing but, let's say, a area in the memory to basically refer an element, right? So think of an example where, let's say, you have a big garage, and in a big garage you have a lot of cars, and each of the cars has a number, right? So to access each of the car, there will be a key right? If you want to take out a car out of the garage, there'll be a key, right? Where is that key? That key would be stored somewhere in the garage, like in a locker box, whatever, right? That key will have some number, right? I mean, usually a key has number. That number is linked to the registration number of the car. That tells you that go to this car and insert this key, and that's when you basically take out. So the analogy is very simple. The analogy is helping you understand that there is a reference uh, data that helps you identify what is the element that you are looking at, right? So for binary trees, yeah, that is what pointers are actually referring to. Uh, so pointers basically help you understand the nodes that you want to get to. Without a pointer information, you will not be able to get to a particular level. And inside that level, for example, at a particular element, right? That is what pointers help you. Now, obviously, binary trees, as we looked at operations of trees, I think you can do all this search, insert, traverse, and deletion, right? There are some advanced operations, which some tutorials also called auxiliary operations because they are not the basic operations. The operations could include like height, identification of the tree, size of the tree, last node of the tree, etc., etc. Right? Where are the applications of binary tree found? Again, very similar to what you had in trees and tech products. Search for elements, right? You can design a search, algorithm using binary trees or any trees for that matter, right? But specifically for binary trees, this becomes memory allocation becomes pretty efficient because there are only two elements, right, that you are looking at. For every node, you are looking at only the left or the right, right? Quite a few compression algorithms are also built using binary trees, right? So there's a lot of application within, I would say, specifically the comp science engineering part, right? Now, the traversals, right? As you would recollect, right? We had discussed that traversals are nothing but a way to basically go from level 0 to level 1 to level 2 and level 3, right? Those are what traversal means. So there are two types of traversals, which is breadth and depth based. Self-explanatory, if I have to say, because breadth means you're looking at this part, which is the a singular level, right? So if I'm looking at level 1, from left child to center to right child would mean breadth. And if I'm looking at depth, that it would mean if I'm in level 0, right? So here this guy, which is the root node, then going to level 1 would be this guy. And then again, level 2 would be either this guy or this guy. So that is what depth would mean, right? So depth-based traversal techniques are there, algorithms, and breadth-based traversal techniques are there, right? So let's look at some of the tree traversal techniques, right? And there is a fair bit of, I think, discussion that is bound to occur if you are asked to design, and I'm linking this to your interviews, right? Which is what you should be all like primarily focusing on. So if I look at, for example, my use case on, let's say, going back to the system design use case on Google Drive, we had talked about implementing a folder structure there, right? Correct? If you don't recollect, then let me help you recollect. There is storage, right? We had talked about in the storage, for example, files for users are stored, right? Frequently accessed files, right? So what does this frequently accessed file mean? Right. So I think frequently accessed files would be accessible in an efficient manner if they are implemented using some technique, right? That is what you should emphasize on because your interviewers can go into the depth of asking that you are mentioning that there is going to be file or folder structure. Help me understand what are you going to implement it with. So then you can obviously mention binary tree or whatever the case might be, right? So now there could be further discussions on how do you, for example, retrieve Rahul's, let's say, folder. Help me understand that. Rahul is a user logged into Google Drive, etc., etc. Help me understand how do I retrieve the Rahul's folder and images inside Rahul's folders, right? So different ways of traversing, right? You can do in order traverse, you can do pre-order, you can do post-order. So here is a tree, for example, right? Again, this image is taken from the internet, and I am giving the credit to the creator, and this is not my own creation. So the concept here is that when you're doing different kind of traversals, right? The traversals are basically helping you retrieve a particular node element. Now, every traversal will have its time taken, right? In computer science engineering terms, it's called time complexity. I'm not devoting any time in this video on that, but I will try to cover it in some video for sure. But understand that if I am trying to get to this element, right? Let's say element fifth, if I have to find this element, right? There are multiple ways in which I can do that. I can go from 1 to 2, 2 to 4. I have not found fifth. Then I go back again to 2 and then come back to fifth. Or I could be doing 1 to 2 and then 5, right? Or I could be doing 1 to 3, 3 to 6, not found. Back to 3, back to 1, back to 2, and then 5. Right? So different ways of traversing. Every traversing will have its time complexity, right? So what in order traversing means is that there is some order in which you are traversing the tree. So in order means you are doing a left subtree first, right? So if you look at uh, the final order, right? One is your root node, right? So how are you traversing? You go to 4, you go to 2, you go to 5, and then you're going to 2 again, and then 1, right? So this is how it is structured. Left subtree, correct? This is your left subtree. Then you look at the current node, which is your 2. Then you go to the right subnode, right subtree, right? Then your current node, right? The current node is a parent node, right? And then basically go back to 1, right? And then here also in order, for example, would be 6, right? Because you're doing a left subtree, correct? Then you're doing current node, which is a parent node, 3, and then right subtree, 7, right? Coming to pre-order traversal, again, every traversal will have some sort of a mechanism, right? So here you are starting with current node. What would be your current node? In this case, it will be root because you're starting with root, right? Which is 1. Then you can go to either 2 or you can go to either 3. There is no, you know, fixed like you have to do. The way it is defined obviously is that okay, you start with left or you start with right. No order as such. You can call it pre-order left subtree traversal, or you can call it pre-order right traversal, right? So here, for example, you do 1, 2, and then 4. Then you come back to 2 again, right? So let's start with this, right? Current node basically 1, right? Then you go to left subtree, which is 2, and then you go to left subtree again, right? Uh, 4. Then you come back to current node, and then because there is you already traversed this, then you go to the right subtree, right? The once you have gone to 5, then where do you come back? You come back to 2. You right. So this sequence here is basically telling you how do you traverse, right? So I think these are the sequences that will vary depending on what traversal you have taken, right? Let's look at this last example, right? The post-order traversal. The post-order traversal would be left subtree, right subtree, and the current node, right? So you're doing a 4, then you're doing a 5, then you're doing a 2, right? So similarly, you will do a 6, then you will do a, which is a left subtree, then you do a right subtree, and then you do current node, right? Now, for your parent node, this was your left subtree, right? That is how you actually started with this. Why did you come to 4? You should always ask this, right? Because the sequence here tells you that. The sequence tells you that you have to start with the left subtree, right? So imagine this 4, 5, 6, 7 is not there. You have only 1 and 2 and 3, right? Where do you start? 2, right? Because it's saying that you have to start with left subtree. Now you got into 2. Again, how do you decide whether you go to 4 or 5? You have to go to 4, right? Because it's saying that it is a left subtree. After 4, where do you go? Whether you go to 2 or whether you go to 5. So remember, if you go to 2, right, from your left tree, then it becomes the in order traversing from 4 to 2, correct? But if you go from 4 to 5, it becomes a post order traversal. And then you go to your current node here, right? So current node is 2, right? So 4, 5, and 2. Similarly, you are now completed with this part, right? So you'll come down to the right subtree, correct? The right subtree is starting with 3. So at the back end, basically, you have already completed this. You are now going to go back to 1. Then you come back to 3 because this is where you're doing the right subtree. So right subtree also where to go, 6 or 7, right? You'll go to 6, right? Because it's saying that when you are at your right subtree, make that right subtree as, let's say, your current node, or like, a starting node, and then you go back to your left subtree, right? So basically this sequence is running in a recursion. It's constantly going back to an order, and that order is actually helping you go to an element, right? So I'll share some of the codes related to it if it is helpful to understand. But do keep on reading about these traversal techniques, because these are like fairly, I would say, easy scoring interview question. Whether you will be penalized or not, I think the way it works is that if there are 5 or 6 candidates and they want to select one only, right, for a product role, especially in companies like Google, Meta, Freshworks, VMware, I think these are standard, like, expectations that you should know about these. Uh, no harm in, I think, knowing more traversal techniques, but bare minimum, I would say, like, you should know about this. So I hope you found this video useful. Do give a thumbs up, subscribe to my channel, and in the next video, I think I do plan to cover heaps and graphs. The way I am structuring this content is that I will cover the concepts first, and then get back to the advanced, let's say, stages where, like, you're looking at algorithms, right? Like the greedy algorithm, right, and then recursion algorithms, and then finally we'll wrap it up with interview questions. That's the most important part, right? So go through these, I think, concepts. Feel free to leave comments if you feel I have not covered anything. Do leave comments, suggestions. I will try to prepare videos that help explain these concepts in simpler terms. So until next time, stay safe, keep watching the videos. Bye for now.